Hello students, welcome back to our channel. So students, we are continuing with probability lectures, and in this video we are going to study a very important theorem from class 12th mathematics chapter probability, and the theorem is Bayes theorem. Bayes theorem is the most important topic in probability chapter of class 12th mathematics. So let's start. Before understanding this theorem, you have to know the basic terms of probability from class 12th, that is, what is conditional probability, what are independent events. So if you haven't seen the first two lectures of probability, you have to watch those lectures first, and then you will be able to understand the concepts of Bayes theorem. So let's start. Let us say that there are n events, e1, e1, e2, e3 up to en, right? And these events are from the same sample space S. Let E1, E2, E3, En are events from a sample space S, right? These events E1, E2, E3, E4, these events are pairwise disjoint. All these events should be pairwise disjoint, which means if you pick any two events from E1, E2, E3 up to En, then those two events will be mutually exclusive, which means if you see the set of any of the two events, there will not be any element common in those two sets. So if you pick any two events, those two events from these events will be pairwise disjoints, right? Okay. And A is another event from the same sample space. From S, right? So Bayes theorem says that probability of any event I, conditional probability of any event from these events, let us say that is the ith event. So probability of occurrence of ei when A has already occurred, that is equal to the probability of occurrence of ei into the conditional probability of occurrence of A by ei divided by the sum of all these probabilities, which can be written as so this is the formula for Bayes theorem, but using symbols we cannot make it very clear to you the meaning of Bayes theorem. So we will go into more deep concepts, and to understand this formula, first we have to understand something which is called the theorem of total probability. Theorem of total probability. What is the theorem of total probability? Let us say we have to find the probability of drawing a red ball. Let us see a situation in which, suppose we have two bags, right? Bag 1 and bag 2. Okay, bag 2. Let us say that this bag contains 3 red and 2 black balls, and this bag has 4 red and suppose 5 black balls. Okay, what is the question? Question is, suppose we have selected one bag at random and we have drawn a red ball from the bag. What is the probability? Right? We do not know which bag is selected. So it is question is given like find the probability of drawing a red ball from any of these balls, right? So when such question comes, generally what kind of questions we have done in probability? We are not doing any question in which two bags were given or more than two urns were given. There was only one bag. Suppose what kind of questions you have done till now? There was only one bag given and it was said that find the probability of suppose drawing red ball from this bag or drawing black ball from this bag, or in conditional probability it was given that first event is suppose of drawing a red ball. So in first event it was said that a red ball is drawn, then what is the probability of drawing second ball as the black ball, right? But now in case of theorem of total probability, there are two bags. We have to select one bag at random and then we have to draw a red ball from that bag. So what is the probability, right? So what we will do, suppose E1, E2 are two events, E1 and E2 are two events of selecting the bag, right? E1 is the event when we have selected bag 1 and E2 is the event when we have selected bag 2. Obviously there are only two bags, so probability of selecting one bag out of two bags is 1 by 2, right? So we can say that PE1 is 1 by 2 and PE2 is also 1 by 2, right? Okay. Now when we have selected the bag 1, suppose A is the event which says that we are drawing a red ball. Suppose A is the event of drawing a red ball. A is the event of drawing the red ball. So what is this probability? A divided by E1. What is this probability? This is the conditional probability of first selecting the bag 1 and then drawing a red ball from bag 1. So this probability is what? What is the probability of drawing a red ball from bag 1? How many red balls are there in bag 1? How many red balls are there in bag 1? There are 3 red balls in bag 1. So this should be 3 divided by the total balls. Total balls are 5, right? Okay. And what is the probability A by E2? This is the probability of first selecting bag 2 and then drawing a red ball from that bag, right? So probability of drawing a red ball from bag 2 is 4 by 9. It is 4 by 9. Okay, now combine all these. So if we apply now what we are doing, if we now apply the multiplication rule of probability, right? Multiplication of rule of probability says first you have selected bag 1, right? This is your first event. Then after selecting bag 1 you have drawn a red ball from that bag, so you will multiply the probability of that event PA by E1. But this is just one of the possibilities, or we can do this thing PE2 into PA by E2. This is also possible, right? So the answer of this question, that what is the probability of first selecting a bag from these two bags and then drawing a red ball, the answer to this question will be this. So 1 by 2 is the probability of this, and PA by E1 is 3 by 5, or selecting second bag and drawing a red ball from that bag, that is into 4 divided by 9, right? So the answer is 3 divided by 10 plus 2 by 9, and we can add this, right? Let's not go into the calculation thing and all. So that is the theorem of probability, that is P E1 into P A by E1. In this case we were having just two bags or two possibilities of selecting the bags or selecting anything, whatever the situation is. So let's say there are n bags, so we will add all this till n times. So last term will be p en into p a by e n. Clear? Okay. Now in Bayes theorem, it is not given that we have to find the probability of some event. It is given that the event has already happened, right? Okay. If we make this question on Bayes theorem, then what kind of question we are going to get? It will say like this: suppose there are two bags containing 3 red and 2 black balls, or 4 red and 5 black balls, and one bag is selected at random and a ball is drawn from the bag. If it is given that the ball is red, what was the probability that it was drawn from bag 2? Got my point? That it is given that the drawn ball is red. We don't have to find the probability that the drawn ball is red. No, it is given that the ball is red. Now we have to find the probability that it is, what is the probability that it is drawn from bag 1 or bag 2. So Bayes theorem is used when we are going in backward direction, right? It is already given that this particular event has happened. Now go backwards and find the probability of the event before that, right? It is given that the ball drawn is red. One bag is selected at random and a ball is drawn from the bag. It is given that the ball is red. What is the probability that it was drawn from bag 1? Such kind of question is going to come in Bayes theorem. So let us say it is asking that what is the probability that it was drawn, what is the probability that red ball was drawn from bag 1. So this should come in numerator because this is the favorable part, right? And this whole should come in denominator because this whole is the total possibility, right? So that's why it is written is like this. If we expand this, suppose we are talking about E1. So P E1 by A is equal to PE1 into P A by E1 divided by PE1 into P A by E1 plus P E2 into P A by E2, and suppose you have n events, so last term will be PEN by P A by En. That's why we have written it like this: PEK into PA by EK, which means we are adding all these terms by after putting the value of k from 1 to n, right? So that is Bayes theorem. For example, let us discuss two very important questions based on Bayes theorem. The number of events that are given in this case, like E1, E2, E3 in class 12 will not be more than 3. You are going to get maximum 3 events, or in most of the cases number of events will be 2. Bag 1 contains 3 red. Oh, this is almost same question. Bag 1 contains 3 red and 4 black balls, and another bag 2, this is bag 1, and another bag 2 contains 5 red and 6 black balls. 5 red and 6 black balls. One ball is drawn at random from one of the bags and it is found to be red. Find the probability that it was drawn from bag 2. Now let us say E1 and E2 events. These events E1, E2, E3, they are very related events. So in the question you will be finding 2-3 events which are very closely related to each other, and there will be one event which is different from them. So that event will be A, and these closely related events are E1, E2, E3 up to En. So E1 is selecting bag 1. E1 is the event in which we are selecting selecting bag 1 and selecting bag 2. So PE1 and PE2. PE1 is what? PE1 is 1 by 2. PE2 is also 1 by 2 because there are only 2 bags, and out of those 2 bags probability of selecting one bag is just 1 by 2. Now A is what? A is event of drawing a red ball. A is the event of drawing a red ball. So if we are drawing, first we are selecting bag 1 and drawing red ball from it, then it is 3 by 7, and now we are selecting bag 2 and drawing red ball from it, that is 5 by 11, that is 5 by 11. Okay, we have to find the probability of what? We already know that the drawn ball is red, and we have to find the probability that it was drawn from bag 2. So we have to find the probability of E2 given that it was red, right? Now just apply the formula of Bayes theorem. If we have to find the probability of E2 by A, so that will be P E2 into P A by E2. Since there are only 2 events, so in denominator we are going to write PE1 PA by E1 plus PE2 into PA by E2, right? Now put these values. PE2 is 1 by 2 and this is 5 by 11 divided by PE1 is again 1 by 2 and this is 3 by 7 plus 1 by 2 into 5 by 11. So 5 by 22 divided by 3 by 14 plus 5 by 22. What is the LCM of 22 and 14? 7 into 2, 11 into 2. So 11 into 7 into 2, 77 into 2, that is 154. Fourteen is into 11, 33 plus 22 into 27 is 154, no? Yes, 22 into 7 into 5, 35. So the answer is 5 divided by 22 into 154, 22 into 7, 35 by 68. So the answer is 35 by 68. Okay, next. Given 3 identical boxes 1, 2 and 3, each containing 2 coins. Okay, there are 3 boxes, box 1, box 2 and box 3. Each containing 2 coins. In box 1, both coins are gold coins. 2 gold coins, right? In box 2, both are silver coins. 2 silver coins. And in box 3, there is 1 gold and 1 silver. 1 gold and 1 silver. A person chooses a box at random and takes out a coin. If the coin is of gold, what is the probability that the other coin in the box is also of gold? Okay. Just wants to ask that what is the probability that it was drawn from bag 1, because it is saying that if a person draws a coin and that coin is gold coin, what is the probability that the bag from which that coin is drawn also has the second coin as gold coin, right? So how many bags are there in which there are two gold coins? So there is only one bag which has two gold coins. So it is indirectly it is asking what is the probability that the gold coin is drawn from bag 1. So now we have three bags, and E1, E2, E3 are the events of choosing or selecting a bag. E1 is bag 1 is selected, bag 1 is selected, bag 2 is selected, and bag 3 is selected. So what are the probabilities of E1, E2, E3? Probabilities of E1, E2, E3 are all equal to 1 by 3, because there are 3 bags, and out of 3 bags if we select one bag, then the probability is 1 by 3, right? Okay, what is the probability? Now A is the probability of drawing a gold coin, right? Probability A is the event of drawing a gold coin, right? Okay, so if we have chosen bag 1 and draw a gold coin from it, then what is the probability? Probability of drawing a gold coin from bag 1 is simply 1, because how many gold coins are there? 2. How many total coins are there? 2. So 2 divided by 2 is 1. Because if this bag has only gold coins, then what is the probability? If you draw a coin, that will be a gold coin. Obviously 1, because there is no other option, right? Okay, what is P A by E2, which means that we have selected bag 2 and we are drawing a gold coin from that bag, but bag 2 does not contain any gold coins, so the probability of drawing gold coin from bag 2 is 0, and the probability of drawing a gold coin from bag 3 is 1 by 2, because there is one gold coin in third bag and total coins are 2. So what we have to find? We have to find that the gold coin is drawn from bag 1. So we have to find the probability of E1 by A. Obviously, it is already given that the drawn coin is gold, right? So what is the probability that it is drawn from bag 1? So this is what that is to be calculated. So let's apply the formula of Bayes theorem. PE1 into PA by E1 divided by PE2 E1 PE1 into PA by E1 plus PE2 into PA by E2 into PE3 PA by E3, not into. Here we should put a plus sign. Okay, now let's put all the values. What are the values? This PE1 is 1 by 3 into PA by E1 is 1 divided by again 1 by 3 into 1. We are not going to write this because PA by E2 is 0. Just write the third one. P3 is 1 by 3 into PA by E3 is 1 by 2. So this will be the answer. This is 1 by 3 divided by 1 by 3 plus 1 by 6. So it is 1 by 3, LCM is 6, 2 plus 1, So it is 1 by 3 into 6 by 3, that is 2 by 3. So that is the probability. Right? So this was Bayes theorem, the most important topic in class 12th, probability. You have to practice more questions of Bayes theorem from NCERT examples and exercise. I'll meet you in next lecture. Till then, all the way.